Alright, so we're going to introduce the law of cosines here and kind of talk about where it comes from and what the applications are. So with the real shift here with the law of cosines, it allows for non-right triangles. So far sine, cosine, and tangent have all been keyed into a right triangle, but this is an oblique or really any triangle that we have this will work for. And so in general, our law of cosines, we talk about an included angle with two sides around it. So if that's our angle A, we're talking about these two sides that accompany it. So that's the pattern that we have to have. And there's going to be three versions of this thing because we have three angles that we're worried about. So we also have b squared equals a squared plus c squared, and then we have c squared equals a squared plus b squared. And we'll notice that that looks kind of like the Pythagorean theorem, right? But we have this other piece added on to the end that we'll talk about where it comes from in a moment. So if we have this problem that we're trying to solve, right, there's our included angle, 118 degrees. We have the 8 and the 6 on the sides that are included, and then we can solve for a. So a squared is 8 squared plus 6 squared minus 2 times 8 times 6 cosine of our angle. And we just plug through the algebra of that, and we get a value, and we take the square root, and that will give us our number. If something's like this, where we have all the angles and none of them are known, we just pick one that we like. So let's say we pick that one, and then we set it up, and we're going to have to solve for the angle. So if we pick x as the angle we're looking for, we set up 13 squared equals 8 squared plus 11 squared minus 2 times 8 times 11 cosine x. We'll solve for it and then use an inverse cosine to get to the x, and that will give us our value as we move forward. So if we're trying to talk about why and where does this law of cosines come from, if we take a general triangle, so we just take a triangle, put some numbers on it, and we put it at the origin, we're going to basically break it into right triangles and then use some properties between them and some algebra to get to the law of cosines. So if we were over at 9, and then this is over 3 up 5, we can start to try to see how we could look for side A. So there's my 9, right? We have some height. If we look at that triangle, there's a 5, there's a 9 minus 3, also known as 6. You could directly solve for A right there just using the Pythagorean theorem. And so a squared is 9 minus 3 squared, 5 minus 0 squared, and we can figure it out. But since this is just a general, we want to generalize it for the law of cosines, we have to kind of bring our trigonometry into it. So we put the rest of the sides, B and C, on there, and then just look at cosine of A. So cosine is adjacent over hypotenuse. So we get 3 over B, or 3 is B cosine A, and then we substitute that in for the 3 up there. And then if we look at that side, sine of A is 5 over B, and that means that B sine A is 5. And so we can put 5 as B sine A, and then 9 is really C. So we could substitute in C up here for 9. So when we do that, this is what we get. We can turn this around, and I don't know, why you would do this, except that you know that you're trying to get the law of cosines, right? We can factor out the negative, and that's the same thing as 9 minus 3. And then when you square a negative, it becomes positive, so you're left with 3 minus 9 squared plus that. Make the substitutions again that we had up here at the top, and we're going to see that we have two binomials that we're going to square, and then we have a squared on the other side. So again, it's just a fancy way to write the Pythagorean theorem, and then we do some algebra to actually come to the law of cosine. So we just write out that binomial, and then however you factor those, multiply them out, whether it's double distribution or FOIL, right? That one is easy, it's minus 0, so it's b squared sine squared a. This becomes b squared cosine squared a minus 2bc cosine a. Plus the c squared, plus the piece from before. Move some stuff around and factor out a b squared, and then you have b squared plus c plus this piece here, plus c squared minus 2b cosine a, and then that's 1 because it's your Pythagorean identity, and so you're left with b squared plus c squared minus 2bc cosine a. That's all equal to a squared, and that is our law of cosines. So that's where it comes from. We could do it on all three different sides and get the other three pieces, but it's the same process as we move through it.